Hey guys, I hope we all are doing good. So in this lecture, I'm going to be covering dynamic memory allocation. This is again a very important topic to understand. Once again, if you're someone who already understands this topic, that's totally fine. You can skip this one and then move on to the next lecture. Before I start the series, I just want to cover some basics for understanding of C, how it works, right? So nobody faces a problem in the future parts, right? So we're going to be understanding four different functions. Let's start with understanding what is dynamic memory allocation in C, and then understand these four functions, right? So here's the thing, right? Whenever you write a program, you must have done something like this. Something like 1, 2, 3. So this is what happens, right? In C, you can declare some arrays, right? And you can declare values as well. So let's say int a equal 4, something like this, right? We can declare values whatever we need at the beginning of the program or in our functions or in the main program, right? But the point is, sometimes we need to dynamically allocate memory. And what I try to mean by that is, sometimes we need memory created while the program is running. I'll try to give an example, right? Let's say um, we need memory for some students, right? We are storing the data for some students. So I don't know exactly how many students are going to be there, right? I'm assuming it can be 100, it can be less than that, it can be over 50 students, right? Now, I've been asked to make sure that my memory usage is correct. I don't waste a lot of memory. I need to make sure that, I'm making sure that my memory usage is very efficient, right? I don't want to waste a lot of memory I use. So instead of just declaring an array at the very beginning of the code, what I can do is I can dynamically allocate it. What I can do is I can write a program so that whenever a new student enters my class or the number of students increases, I can run the program and it will automatically generate more memory for me, right? And what happens is that this dynamically allocated memory is stored inside the heap. I explained that in the previous lecture. So we basically have something like um, so we have something like stack, we have heap, right? We have data segment, and then we have the text segment as well. So kind of this is again a very basic diagram of it, but the point of this video is that we need dynamically allocated memory, right? um, a lot of cases we don't know exactly how much memory we need, and we don't want to waste too much memory in the beginning. So what we do is we dynamically allocate it, meaning while the code is running, the program will create memory for us, right? How much a particular like the ask is, or it can basically even extend the memory we need, right? So for example, maybe we started with needing 5 integer memory space, but now we have 10 integers and we need to store that. So that can also be possible, that we can um, make this array bigger than what it initially was. That's not possible with this type of an array that you initialize at the very beginning, right? I cannot resize it while the program is executing, right? Okay, I think that's a pretty decent overview, but I can summarize it once again. So this memory is created in the stack, it stays there, and it gets deleted once everything is done, right? Heap is what is used when we need dynamically allocated memory, or we need memory creation while the execution of our code, right? Let's try to understand what are the four basic functions in C, right? And how do we use them? Before I start, I'll try to explain why are we doing this in C again. So look, while everyone uses Python nowadays, most of the coders, programmers use Python, but Python is a very slow language, right? What happens is Python is a high level language, but the code behind it, whatever's happening, is actually happening in C, right? So when you create an integer in Python, or when you create like an array or a list, in actual behind the scenes, it's being written in C code, right? And this C code is going to get converted to assembly code. Now the problem is that Python gets converted to C code and then to assembly code, and it's a very slow language, right? When it comes to tasks which require very efficiency, right, and tasks which require programs to be very fast at what they do. And let's talk about finance, right? A lot of these trading applications or trading platforms, if you heard about Jane Street or whatever, their trading algorithms are written in C or C++. And the reason for that is because C, C++ are very fast languages, because they are very close to assembly code, right? In a sense that their translation to assembly code is pretty fast, right? Python needs to get converted to C code, and then it gets converted to other code, which makes it very slow language, right? Even though it's very easy to understand, but it's a very slow language in that sense, right? So that's the reason for understanding everything in C. This is under the hood, what's happening inside Python, what's happening behind the scenes, right? Okay, let's try to understand what is malloc. So it basically allocates block of memory of a given size in bytes and returns the pointer to the first byte of that block. Returns null if failed allocation. Right. So this is just a very basic one. Whenever you're gonna dynamically allocate memory, right? I'll try to give you an example. Let's say I ask you to write a code. You're supposed to input the number of students in your class, and then based on that, you're supposed to create a block of memory for it, and then store their IDs. So what you're going to do is, you don't really know at the very beginning, so I cannot initialize an array. I would have to dynamically allocate it, right? So what I can do is, let's say I have 5 students, right? So this is how you initialize using malloc. Let's try to understand what's happening, right? When I say int star ARR, this is a pointer. I explained this in the previous lecture. This over here basically means that this is an integer array over here, right? So this is kind of like telling the compiler that whatever memory I'm creating, it's actually an integer. This points to an integer, right? This array pointer we have, it points to some integer array, right? This is the malloc function. This is how you write it. And if I've written down 5 multiplied by size of integer. If you don't understand star basically means, in terms of coding terms, it's basically multiplication. So I'm saying 5 multiplied by the size of int. Let's try to understand what this means, right? So size of int is going to give me how much size it needs in the memory. Like different data types need different amounts of memory. So integer need 4 bytes, chars need 1 byte, and based on that, we need to declare different sorts of memories. Problem is, I cannot store integer in a space for a char, because char needs less space while integers need more space for storage, right? So we need to make sure that we declare it properly. So what I mean by this is, so 5 multiplied by size of integer, so reserve a space for me for 5 integers, right? If I wanted a space for different characters, then I would say 5 multiplied by the size of char in this case, right? Okay, so let's try to understand what the next part means. So if this successfully returns, it's going to return the pointer to the first element, right? To the first byte of that block. Let's try to understand what's happening. So whenever you declare it, right, there would be some memory created in the heap for it, right? Something like this. So let's say this memory gets created, 1, 2, 3, 4, 5 for your integers. What it's going to do is, if let's say this is the address 06000, right? Let's say if the beginning of the first byte of this memory space is 06000, it's going to return it to this int star ARR. So this over here would actually have the address to this memory block inside the heap, right? Does that make sense? Okay, so I hope malloc makes sense. And the second point to understand is, it's going to return null if failed allocation, right? So we need to make sure that our code doesn't have errors, right? So if you understand that, we need to make sure we do the error checking in our functions or whatever code we write. So a general practice is, if malloc is successful, it's going to return the pointer to whatever array is created, right? If it is not, if it's not able to allocate the memory, it's going to return a null. So what we usually do is, we create a if-else statement, right? Something like this. So basically, if allocation is not successful, then we can return a message that malloc allocation failed. And if it is successful, then we can return the array pointer, right? Okay, let's try to understand what is the calloc function and what it does, right? So calloc is basically just the malloc function, but there's only one difference. So the thing is, when you create any array, right, whatever it is, you reserve memory using the malloc function. These things over here, right, these spaces, they contain garbage values. Like, they don't contain any like specific value or anything, right? So it could be anything. But the thing is, sometimes we need to have some specific integer being stored inside these arrays, right? And that's exactly what calloc does. So like malloc, but initializes all allocated memory to 0. So it works exactly like malloc, but what it's going to do is whatever memory it creates, it's going to store a 0 inside it, something like this. Now, question might be, why is it important again? So think about this, right? Let's say you're creating a matrix, or let's say you're creating a 2D or a 3D array, and you don't want garbage values inside your matrix, right, or your 2D array. So what you can do is, you can, instead of using malloc, you can use the calloc function, because it's going to do two things for you. It's going to not only create a dynamically allocated array, but it's also going to store zeros in it, right? So you know that wherever you have 0, that means it was already initialized, and wherever you have different values, you can store them in a different place, right? Okay, so once again, there's just a small difference in the structure of malloc and calloc. Over here, if you notice, it accepts two different arguments. It accepts 5, comma, size of int. It's just like this, but instead I have to tell how many blocks of memory I need. So I need 5 blocks of memory, and what is the size going to be for each block? It's going to be the size of integer, right? So in this case, in the malloc one, I was straight up giving how much memory I need, which was 5 multiplied by the size of an integer, right? But in this case, I give how many blocks along with the size of one particular block, right? That's just the only difference. So pretty much the same thing. To summarize, malloc and calloc both dynamically allocate memory for us. Only thing with calloc is that it reserves or it keeps 0 inside those initialized arrays, right? Okay, now let's try to understand the realloc function. And before I explain what is realloc, let's try to understand one more thing, right? So let's say I tell you, I'll give you a task, right? I tell you, okay, so first you need to create a space for 5 students, but in the future, it is possible that more students can enter the class. And you need to make sure that it's happening while the code is running. So first, let's say we created a dynamically allocated space for 5 students. But now in the middle of the program, we realize that number of students has increased. So we need more space. And that's exactly where realloc is going to help us, right? So if we want to resize a block of memory, example I've given over here, right? So resize basically means, let's say I created a block of 5 integers, but now I realize inside my code that, okay, I actually need 10 integer space, right? And that's exactly where I can use the realloc, right? What it's going to do is, there's few things to understand for it. It can do two things. It can either increase the size of that existing array. So maybe it looks at this array, right? And it's going to kind of increase the space next to it. But if it feels like, if it knows that, there's no space available after this array, it's going to do one very important thing, right? So it's very important to understand. It's going to go to a different place, right? Create a new memory space, put whatever was in the original array into that new array, and then return that pointer to the array, right? I'll try to explain it one more time. So let's say that we had an integer space for 2 elements inside the array we created, right? Let's say we created a integer array for 2 elements. But now let's say that we need a space for 4 elements while the code is executing. So realloc, what it can do is, it can either extend this and add, like it can extend it. But if it sees that we don't have enough space, right? So if we feel like, let's say in the memory inside the heap, there's something else stored after this memory block, right? So what it's going to do is, it's going to go to a different place, right? Create a memory for 4 blocks. It's going to copy these values, store it inside this new memory block, right? So it's kind of like, even though you can do it in a longer way, you can use a malloc, create a new memory, and then move whatever variables you have in the original array to that array. But it's kind of like realloc is like a more easier function, right? It already does that for you. If you need more memory, it's gonna first it's gonna check if we already can extend the existing memory. If not, then it's gonna create a new memory block, and then it's gonna move everything from the old memory block to the new one, right? Okay, and this is the basic structure of it. So let's say we had created this ARR, right? This is how we basically initialize it. ARR equal int star, realloc, and then we give the array pointer as well as how much size we need, right? So let's say originally this array was 5 integer. It could store 5 integers, with this function, now it can store 10 integers, right? I hope that makes sense. Once again, it's important to understand these very basics because just like I said, this is what's happening inside the hood, right? This is how elements are actually being created, even if you write code in Python, right? So important to understand. Last one is the super important one, and you don't want to miss this part either, is the free function, and it is used to release the memory we have, right? So in the last video, I explained that there's something very important, right? Heap does not remove the memory itself. It does not automatically remove the memory we used. So what we got to do is we got to make sure that whatever memory we have used in our code, right, we give it back to the computer once our code exits, right? And we do that using this free function. So let's say I initialize this array, right? I create an array of malloc of 5 different integers. I need to make sure that this memory, whatever I created, is returned back to the computer once my code ends. Otherwise, it could lead to memory leaks, which I can explain you in future in the next part of the video, right? So very important, we need to make sure that we return the memory to the heap, and that's what we do using this free function, right? And one more important thing to understand is once you free it, it's a good practice to set the whatever array you had to null, right? Let's try to understand why exactly we're doing this. So what happens is if you had this pointer, right? If you don't set it to null, it can be pointing to some freed memory inside the code, right? Freed memory in the sense that it can be pointing to some memory address inside the code, but our actual memory doesn't exist there, right? So let's say you created this array, right? When you free it, it wouldn't be there. But this pointer, right, this ARR would still be pointing to it. So let's say somebody, you made some code and you're using dynamically allocated memory inside it. Let's say a new intern or somebody comes up, and what they do is they try to use this array, even though you have previously freed it in, like in a other part of your program. What's going to happen is it's going to give you errors, right? And to prevent those errors, what we do is once we free the memory, we set it to null as well, right? So it doesn't lead to any errors and weird conditions inside your code. Right, so this is a good practice. You should always make sure that you do it in your C code. And yeah, that's pretty much it. So let's move on to the next topic now. But I hope you guys understand what is the basic point and all these 4 functions.